Hello everyone, my name is Dr. Roshan Kumar, and in today's series I will be talking about chromatography technique. This is one of a widely used technique for the separation of variety of mixtures. This particular term is from a Greek origin comprised of two words, chroma and graphein. Chroma means color and graphein means to write. The separation can be done at a small quantity level from a complex mixture. So coming on to the history of this particular technique, this technique was first discovered in 1800 by a German chemist named F.F. Runge, who first separated dyes using filter paper and water as a mobile phase. Later on, this technique was adopted by Mikhail Svet. He was a Russian botanist who in the year 1906 first separated different pigments from the leaf extract. In this experiment, he used a packed glass column filled with chalk as the stationary phase and used petroleum ether as the mobile phase. So in current scenario, the aim of chromatography can be broadly divided into two types. One is analytical and another one is preparative. In analytical method, the aim is to analyze the chemical composition of a mixture, whereas in preparative method we use it to purify a substance from the mixture in sufficient quantity for further downstream processing. There are few terms that is often used in chromatography technique. I will be talking about all these terms one by one. The first term is analyte. Analyte means the sample that is used for separation during the experiment, whereas the chromatogram term is basically the pattern of separated substances obtained by chromatography technique. The term differs from technique to technique. The two terms elevate and elevate. Elevate refers to the mobile phase that leaves the column. In the right hand side you can see the elevate enters the stationary phase, whereas the elevate leaves the stationary phase. Elevate carries the analyte, whereas elevate is basically a mobile phase which when enters in the stationary phase tend to move the sample depending upon the affinity with the elevate. There are two phases in any chromatography technique. One is mobile phase and another one is stationary phase. Let's talk about them one by one. The mobile phase. In this phase, the liquid or gas that flows through a chromatography system which moves the mixture to be separated at different rates over the stationary phase is generally referred as mobile phase, whereas the stationary phase can be solid or liquid depending upon the chromatography type we are using, on which the mixtures to be separated are selectively adsorbed. There is one term that is often used in this particular technique, that is retention time. In today's modern chromatography methods, there is a detector that is always associated with the machine that helps us to detect the different components present in a sample. So the time taken by a particular sample or analyte to pass through the system, that is from column inlet to the detector, is referred as retention time, and it varies for different components in a mixture. What is the principle of chromatography? As we know, different molecules tend to have different characteristics such as molecular weight, adsorption, partition, affinity. So by using these characteristics of the molecules, it can be used to differentiate or separate these molecules in different chromatography methods. Some molecules tend to stay longer in the stationary phase while the other pass rapidly along with the mobile phase. Here I would like to mention an example. Let us suppose we are using a stationary phase of paper chromatography in which cellulose is acting as a stationary phase which is polar in nature, and by chance we are loading a sample that has polar component. So in this case the polar component will have the affinity for polar cellulose and it will tend to move slowly as compared to the non polar fraction of the mixture which will pass along with the mobile phase. There are different types of chromatography that we use, but it can be broadly divided into two types: adsorption and partition. In adsorption, one phase is always solid while the other phase can be gas or liquid, whereas in partition, one phase is always liquid and another phase can be gas or liquid depending upon the method. And different types of chromatography, as for example column chromatography, can be adsorption, as at the same time it can be partition depending upon the stationary phase we are using in this particular technique. So coming on to the adsorption chromatography, in this particular chromatography, it is basically based on adsorptivity. Different compounds are adsorbed on the adsorbent. Thereafter, the mobile phase moves over a stationary phase, leading to the separation of the components with higher absorptivity to a lower distance and with lower absorptivity to a higher distance. Then comes the partition chromatography. In this particular chromatography, the component of the mixture gets distributed into two liquid phases due to the differences in partition coefficient during the flow of the mobile phases in the chromatography column. Now we will talk about different chromatography methods. Let's start with paper chromatography. As the name suggests, this chromatography uses a sheet of paper or a stripe of filter paper. This technique is used for the separation and identification of relatively small chemical substances by a moving solvent on the sheet or a stripe of the filter paper. The substances to be identified are spotted near one end of the paper. In the right hand side, you can see a apparatus in which paper chromatography is running. What we generally do, we load the sample at the base of the paper 1 centimeter away from the bottom, and then we place it into a system which is filled with mobile phase, and this mobile phase moves along the sample and the sample gets separated depending upon its nature and the affinity with the mobile phase. So the principle of the paper chromatography is that the paper is made up of cellulose, a polar substance, and the compound in the mixture travel farther if they are non-polar. Whereas if the substance that is polar in nature and it binds to cellulose, then it will stick with the cellulose and move slowly. Therefore, the conclusion is polar attracts polar and non-polar attracts non-polar. There is a term that is frequently used in paper chromatography, that is retention factor or RF value. It is basically the ratio of distance traveled by a solute and distance traveled by a solvent. As for example, we are using a sample which we load at a point, and we see at the same time this sample runs x centimeter, whereas the mobile phase travels y centimeter. Then the RF value can be determined by x is to y ratio. If the RF value is 0, it means the solute remains in the stationary phase and thus it is immobile. Whereas if RF value is 1, it means the solute has no affinity for the stationary phase and traveled with the solvent. The next technique is thin layer chromatography. As the name suggests, it uses thin layer of silica gel or aluminum oxide or cellulose. All these material can be coated on a sheet that can be either made up of glass, aluminum foil or plastic. And then we can use different volatile organic solvents to separate the component after loading it on the stationary phase. In the right hand side, you can see the sample has been loaded 1 centimeter above from the base, and then it is placed in well saturated chamber containing the mobile phase. And when the sample mobile phase travels from the bottom to the surface, it along with it the different components of the sample also migrates from one end to another, and based on that you can see there is different pattern of bands generated in the right hand side. What are the advantages of using thin layer chromatography? First of all, it is very simple, rapid and cheap. At the same time, It is faster and can give us a better separation. If we use if we use this technique several times, and then at the same time, if we know how to control different parameters, we can also obtain a better resolution, as well as we can also quantify the small and pure fraction of different components. This particular technique is used to identify the unknown compounds and helps in determining the purity of the mixture. The next chromatography is gas liquid chromatography. It is also referred as gas chromatography. In this particular technique, gas is used as a mobile phase, and most of the time it is helium, which is inert gas. The stationary phase is comprised of a column. As you can see in the right hand side, the column is placed in a column oven, which is typically packed with a thin layer of liquid or a polymer. This polymer can be anything, as for example, it can be cyanopropyl phenyl dimethyl polyxylosane. You can see all these things in the last section of this slide. And the choice of column depends on the sample that we want to separate. And in the flow chart, you can see the carrier gas passes through the column, and in between, the flow of the gas is regulated by the flow controller. At the same time, there is an injector port that helps us to inject the sample, and based on the size of the column, the sample gets separated, and it is well detected in the detector, which is finally recorded in a system. Now we will talk about ion exchange chromatography. As the name suggests, in this particular technique we can easily separate ions and polar molecules based on their affinity to the ion exchanger. In the right hand side, you can see we have a packed column that is filled with polymer beads with negatively charged functional groups, and at the same time we are separating a mixture that has that poses all the charges, that they have large net positive charge, they have net positive charge, they have net negative charge, they have large net negative charge. As we know, opposite charges attract each other. Then in that case, the polymer beads which poses the negative charge, they will have maximum affinity for the large net positive charge and least affinity for the large net negative charge. And because of this, the first thing that will come out from this column will be the ones that will poses the large net negative charge. So you can assume that using this technique we can separate molecules, charged molecules especially, that can be proteins, nucleotides and amino acids. Now the next technique in this series is high performance liquid chromatography. As the name suggests, in this particular technique you can see the solvent is interlinked with a pump, and then it passes through the HPLC column, which then gets attached with the detector, which is finally recorded in a system. So this technique is used to separate, identify and quantify each component in a mixture. The principle lies behind this particular technique is to pass a pressurized liquid solvent containing the sample mixture through a column filled with a solid adsorbent material. Each component in the sample interacts slightly differently with the adsorbent material, causing different flow rates for the different components and leading to the separation of the component as they flow out of the column. So today I have talked about different chromatography techniques. Thank you so much. Thank you for your